Welcome to Notes for 1.6, Standard 1.6 for Earth and Space Science, which deals with the formation and the age of the Earth. So we start with a claim. Earth formed through the process of accretion at the same time as the rest of the solar system. So if this statement is accurate, there needs to be evidence to support it. The first piece of evidence we're going to look at is we study and date the age of space rocks, like moon rocks and meteorites. Those moon rocks and meteorites are space rocks. And so, whatever their age is, that's the age of the Earth. So we go back here. How does this evidence here connect it to this claim here? So, you need to know this evidence. What we will do is do something called a reasoning. And that reasoning is you thinking, how does this connect to this? And so what I wrote for my reasoning, which is not something that is set in stone, but is just an example of a reasoning that would connect those two things, is since these space rocks, meteorites, meteorites and moon rocks were formed at the beginning of the solar system, their age is the same as the solar system. So if Earth formed through accretion at the same time with the rest of the solar system, the age of these space rocks must be the age of Earth. So that was my reasoning. And it now connects this evidence of dating these space rocks to the claim. So now let's look at another piece of evidence. We find ancient Earth rocks on Earth and we date them. And these rocks formed near the beginning of the Earth when the crust cooled. So after Earth formed, the crust cooled. And these ancient rocks now has to support this claim. How does that support the claim that Earth formed through the process of accretion at the same time as the rest of the solar system? So we look at that, and we have to, again, use our thinking caps and come up with a reasoning to why these connect. So my reasoning I came up with, which could be different than your example, is since these space rocks, going back here, reasoning, dating these ancient Earth rocks gives us a minimum age of the Earth. We know that Earth formed from accretion with the rest of the solar system. So the first rocks forming had to happen after this process. According to the dating of these ancient rocks, this is accurate. So that connects your reasoning to your evidence to your claim. So now let's look at the third piece of evidence. What you need to do is we look at the appearance of the inner planets and the moon, and they appear to have impact craters, and Earth does not. So again, how does the fact that there are impact craters on inner planets and moon, how does that connect to this claim that Earth formed through the process of accretion at the same time as the rest of the solar system? Well, we have to use our thinking caps again and come up with a reasoning for this. If all of these other objects in space have impact craters, that must mean Earth did once as well. These impact craters came from the beginning of the solar system when there were constant bombardments between space objects. Then Earth must have formed through accretion with the rest of the solar system. Again, that connects our evidence to our claim. Your reasoning might be slightly different than my reasoning. It's all about thinking. Okay. So we have to identify the stability in change and the conditions within our situation. In science, it's important to identify the stability and change in the conditions and things. So stability is the objects in space have not changed from the beginning of the solar system. So that means with this, we are talking about the space rocks which were meteorites. We're talking about those ancient earth rocks. And we're talking about the impact craters. And where were these impact craters? They were on the inner planets in the moon. These are all things considered, all conditions that are staying the same. The space rocks didn't change. The ancient earth rocks haven't changed. And these impact craters on the inner planets in the moon haven't changed. This can be used as a standard to measure other things against. But now we have a change, and the change in this system is the Earth. It has gone through many changes in its history. Its surface has changed. Its layers have changed, or not its layers have changed. Its Earth has been much different. So the importance of identifying something that's changed, it's good to figure out how, why, what, and when with that change. So what was causing it? And so in this case, we were wondering how the Earth formed and when it formed. So when did these changes take place? So we go to the next slide, and we have to connect the stability and change to the explanation. So knowing that Earth has changed allows scientists to know that we cannot only study the Earth, determine its age and how it formed. So we can't use the Earth. The Earth has changed, so we can't use it as the condition to figure out its age. So that means scientists must look for a stable condition that will identify the age of the Earth. So what are the stable conditions? Well, they will look at those pieces of evidence. What scientists have found to be stable from the beginning of the solar system is space rocks and the surfaces of the inner planets, okay, as well as ancient Earth rocks from when Earth first formed. They haven't changed either. It might be hard to find, but they haven't changed. So studying these stable conditions allows us to determine the age of the Earth, even though Earth has changed. Think about a system in science, there's always going to be changes. And if we can find a standard place of stability, that can help us in determining how the things are different. So again, it's the idea of connecting this stability and change to our claim evidence reasoning explanations. So that's kind of where I want most of the class to get to. If you would decide to go above it and beyond, you need to know about radiometric dating. This process is based off the idea that every element decays at a fixed rate. So if we can figure out how much has decayed, we know how old it is. This process uses half-life, which is the fixed decay rate for an element. We call this an absolute dating method, which means it can tell the exact age of an object. So we use radiometric dating. So examples of radiometric dating, these websites here will be a good example of this information. So if you need, there's a video here, and then this talks about absolute dating, and it's a very good website on radiometric dating. You can use it to help you determine dates of the Earth. Okay, this other one's not coming up. So how are we going to use radiometric to date the Earth? Well, we take samples of the ancient Earth rocks and absolute date them using radiometric dating. We also take samples of the moon rocks and meteorites and absolute date them using the meteorite. Okay. And these are pieces of evidence used in determining determining the age of the Earth. So that when we talked about dating these rocks and studying them to determine their age, we actually use the system of radiometric dating. So you have to explain it and then be able to tell me where we use it. Hopefully this lecture has helped.